Hi guys. Okay, so here's a video on 4.3, the product and the quotient rule. And I already went over this in class, so again it's going to be brief. I'm going to include a few examples. But the product rule simply says that if you have the product of two functions and you want the derivative of that product, then you take the derivative of the first factor, multiply it times the second, plus the derivative of the second factor multiplied by the first. We can do this in shorthand notation if you like, f prime g plus g prime f. Alright, meaning take the derivative of the first factor first, and then take the derivative of the second factor second. So fig plus gif, alright, meaning that the derivative of f comes first, and then gif comes second. The derivative of the second factor comes second. So a simple example is 3x squared sine of x. If I want the derivative of this, then I can say that I want to take the derivative of the first factor times the second, plus the derivative of the second factor times the first factor. And this is easy now. I've written it out. I haven't taken a derivative yet, but I know the derivative of 3x squared is 6x, and I just multiply that times the sine of x. And I also know that the derivative of the sine of x is the cosine of x times 3x squared. Now if you wanted to write this properly, or using math etiquette, you could say 6x sine of x plus 3x squared cos x. And by the way, we could simplify that a little bit more. I could pull out a 3 and an x from each term. So let me do that. And rewrite what's left. If I divide this term by 3x, I'm left with 2 sine of x plus x cos x. And that's it. Another example I wrote down is e to the x tan of x. Again, it's a product, so I'm going to write it out in product rule format. Derivative of the first factor times the second plus derivative of the second factor times the first. And now I'm going to take the derivative. Derivative of e to the x is just e to the x times tangent of x plus derivative of tangent of x is secant squared x times e to the x. And guess what? I've got an e to the x in both factors, so I can pull that out if I want to simplify. I'm left with tan of x plus secant squared of x. Done. Okay. Now the quotient rule, so I'm going to use the shorthand notation. A function divided by another function. If I want the derivative of that. So now we're on quotient rule. Well, the rule says we take the low and multiply it by the derivative of the high, right, what's on top, minus the high times derivative of the low over low squared. The important thing is for this first, so in here, to the left of this minus sign, you must take the derivative of the numerator. Whatever's in that numerator, the derivative has to be taken there first, not over here. Otherwise you're going to have a big problem. So you have to follow this. The other way we say it is low d high, meaning low times derivative of high, minus high times derivative of low over low squared, whatever that might be. Okay, so an example. I don't know. Ella, give me a math example. Y equals to 5x cubed over sine of x. Okay? So, derivative now. Now I'm not taking the derivative, I'm just writing it out according to the rule. It's low times the derivative of high minus high times derivative of low over low squared. And here we go with the focus again. So that's equal to the sine of x times 15x squared minus 5x cubed times, I didn't mean a squared, I mean a derivative. The derivative of the sine is the cosine of x all over low squared. And if I want to, again, math etiquette, I can rewrite this as 15x squared sine of x minus 5x cubed cos of x over sine of x squared. And I can go a little further maybe and take out a 5x squared from the top and rewrite this as 3 sine of x minus x cos x all over sine of x squared. I'm done. Another one might be f of x equals, I don't know, e to the x over tangent of x. So again, I'm just making these up. So according to the quotient rule, I can write this as tangent of x times the prime, or e of x prime, minus e to the x times the derivative of the tangent, all over low squared. Low d high minus high d low over low squared. And that's going to give me tangent of x, e to the x, so I've taken the derivative of e to the x, minus e to the x times secant squared of x, that's the derivative of the tangent, over tangent of x squared. And again, I could pull out, say, an e to the x on top and be left with tan x minus secant squared x all over tan x squared. Or, you can also write that as e to the x times tangent of x minus secant squared of x all over tangent squared of x. These are equivalent. Okay, so I hope that helped with product and quotient rule, and I will see you on Thursday. Have a good night.